How's it going, guys? My name is Avery, and welcome to the channel where we make and discuss games. Before we start on this tutorial, we're making the game Pong. I just want to remind you guys of our goal to get 100 subs this month. At the beginning of the month, we started at 400. We're halfway to getting to 500 already. So if you guys are new here, you know the drill. Go ahead and click that subscribe button, hit the bell to get notified for all your game dev needs, and like the video if you enjoyed it, and watch the whole thing. Well, let's jump right into it. So for our game that we're making, it's going to be a short tutorial. We're going to explain how to make Pong and all the basics. We're going to be using SDL2 and a library using SDL2 for font. And I'll have this link in the description where you can go ahead and download it. If you're on Linux, you can just go ahead and use apt-get. You can download it with libsdl2-dev. And there's also going to be the font package. The link's going to be in the description. And you can also download this in the apt-get repository with libsdl2-tttf/dev. But I'll have all these things in the description below, so you guys can just go in there and you can install this and get it set up. It's going to be super easy. And along with that, we're going to be using this font class right here. It's called Pepo. It's kind of a pixelated font. It doesn't matter if you need this one, but if you guys are interested in using this font, we're going to be using it to keep the scoreboard on our Pong game. I'll have a link for the download in the description. But if you guys have any sort of just .ttf file for any sort of font on your computer, you guys can go ahead and use that as well. It doesn't really make a difference, but this is the font we'll be using in this video, and you guys can also get that in the description below. So getting started, the first thing we want to do is include our libraries. So we'll just do include, and we'll do SDL2, then SDL.h. And then right here, we'll include it once again. And this is for our font library. It's going to be called this right here. Depending on how you installed it or where you installed it, if you're on Windows, Mac, or Linux, it's possible these locations might be a little different. You may not need to include that. And if you have the actual file is saved in the same folder, you're just going to want to do this as well. If it's not in your library folder, and you can direct it to the actual file itself. Either way, this is how you just set it up. And we're also going to be including the IO stream so we can print things to the screen. And with that, let's go ahead and actually get started. We're going to make our main function int main. And depending on your compiler of C++ or G++ or GCC or whatever you use, maybe it's built into your IDE, you may need to include some arguments into this main, but we're just going to go ahead and skip that. And in here, in our main class, we're going to set up our window, and we're also going to create our game loop. So to set up our window, we're going to call some variables above, initializing them. And these variables will need a render. And this render is what is going to draw things to the screen. And then we'll create a window. And this window will just be what holds the render. And we'll also call our font. Let's call this font right here. And then we can also set a color. So when we draw to the screen a rectangle or we draw some sort of font to there, we can just have a color already set. And we'll have a variable right here, we're running, that we're going to tell the game that it's running. And we're also going to set up, so there's a simple frame loop. So we'll just do frame count, and I'll explain this all in a second, how it works, and then last frame, and FPS. There are several ways of doing this. There's several different game loops that people set up, but this is just a basic one that we can use. And now in our main class, we're going to just want to initialize some of these things, create our window. So we also want to test for things, make sure there's no sort of null, there's no error. So we'll just do SDL init, and then we can do SDL init everything. So we're just making sure everything was initialized and greater to 0, so that means there's no error. And then, but if there was, if it is, then we can just say failed at SDL init. And then inline. So that's just checking for any sort of error. We're going to have another check, just checking to make sure the screen was created correctly. So let's do SDL create window and render. There's two separate functions, but this function does both of them at once. And we'll create a width for the window. We'll just call it width for right now. And we'll set it up above in a second. And then height. And then we can pass in some extra SDL flags right here. So if you wanted to do, you can do SDL window full screen, but we'll just set it to 0 for now. And if you want to set the full screen, when you set your width and height, you can set that to the width and height of your actual screen, or you can set it to something smaller and it'll scale it out for you. I think if you set it to something bigger than your screen, it might give you an error, it might not make it full screen, it might just be a large window that doesn't fit. But yeah, if you guys want full screen, just go ahead and do that. And then we'll pass in the window, and we'll also pass in the renderer. Now let's make sure that one actually ran. So if it failed, we can just say that. And failed at SDL create window and renderer. And it's right here, end line. So what these things are doing, SDL init, it's just initializing all the SDL library, and then SDL create window and render sends in the width and height, and then it sends in the window and render. And if these things return something that is greater, or that is a negative number, that means there was an error, and we're just going to say there was an error. And up here we'll define the width and height. So we'll just do define width, and we'll just set it to 720, like I had in the example, and define height, or I'll have the example that I'll show you in a bit. And there it is right there. And now we can jump in a little further. We're going to have to initialize our font as well. So let's do that. And if you wanted to, you can go ahead and do this in the if statement as well, and you can also check to see if there's a font that failed. I usually, instead of just doing that, you can do this right here, and you can just do TTF open font. And now you're just going to want to direction it to where the font is, and mine's just in the same directory. It's the name of the font, and also give the font size. So let's call the font size up here. Define font size, and we're going to go ahead and give this font size, and we're going to set it to a 32. And now you can check, if you wanted to check to make sure TTF was initialized correctly, you can run the if in here and set it if it was 0 is greater. You can also check to see if the font's null, and if that happens, maybe the file was in the wrong location, or didn't get initialized correctly, or the library is not linked. But that's just a simple way to check it. And now that we've got that done, we're going to go ahead and we can set up our game loop. So in here, where you have this variable up here called running, so as long as it's running, we'll just say right here, I'll be looping. So all running. So to break this loop, we'll just set running to 0. So right here we can set running to true. And yeah, so now it's just going to go into an infinite loop. And along with that, we're going to set up our FPS counter. We're going to be using these things we had right here. To do that, we're just going to set our last frame. And then this one is going to be use SDL get ticks. And that's going to tell us what frame we're on right now. Not what frame, but it's going to tell us the second that we're on. And then we can just check to see if this last frame is greater or equal to the last time, plus 1000, 6000 milliseconds. And if it is, then we're just going to reset everything. And we're also going to use some of this stuff to set up in our render function as well. So it's going to go in there. And then last time equals last frame. FPS equals frame count. And then frame count equals 0. So up here we're going to set up another function called render. Let's call it void render. And in here we'll set up the rest of our frame count. And it'll just say frame count plus plus. As we can see down there, we set it to 0. So that's a way to reset it. And we can also do right here timer FPS. So we have set up there. And we'll set that to SDL get ticks minus last frame. So now we can see the difference. And now let's go ahead and we'll make it so it's 50 or 60 frames per second. So if it's just timer FPS is greater than 1000, then that's 60 frames per second. And now right here we're just going to set a delay. So SDL delay, It's going to sleep the screen for a split second, or sleep the whole program, and we'll delay it by that much, and minus timer FPS. And that's just a simple way to have a frame counter, make sure it's 60 seconds at a time. So if your game, it'll always run the same speed on any computer you're at. You're not going to have to worry about some games running faster than other ones, because they're going to be the exact same. And now going back into our for loop right here, and go ahead and actually call some of our functions. So we can call this render function. And before that, we'll call these two other functions that we're going to create. One will be an update function, and one will be an input function. This update is where the game is mainly going to be played. It's going to have a lot of logic for the game. The input's going to check for keyboard inputs. It's going to check to see if you close the window. And the render function is just going to be used to draw everything. And once we leave this while loop, we're going to have to close some things. So let's do ttf close font. We can pass in the font. And we can also do SDL destroy window, or destroy render, and we destroy the renderer. Then SDL destroy window, and we pass in the window to destroy that. And then along with that, let's do SDL quit. Now let's go ahead and just double check, make sure everything's running right. So to compile it, you can use G++, summon Pong.cpp, and include our libraries. And as so. And timer was not declared. Oh yeah. So let's just declare these things right here. Void update and void input, and this timer FPS. Set that right there. Right here. This last time it wasn't declared. We're gonna go ahead and declare it right here above it. Or we just do static int last time equals 0. And now let's go ahead and compile it one more time. And as you can see, we should have this window. Though nothing's actually being rendered to it, this button shouldn't work, so let's just force close that. Maybe you guys don't want to open it yourselves yet. And now we're going to set up some input, and so we can actually close the window correctly. So in this input function, it's going to be the easiest of all the functions that we're going to be doing. We'll do an SDL event, and we'll call this event E. And this event's just going to keep track of what things are happening, and we'll also create an array that holds all the key presses. This works as well with the SDL event. You don't really need to do this, but I just find this a lot simpler. And we'll just do get keyboard state and then null. So every time it runs this input function, it will just get an SDL event, and it'll also get all the key states, and it'll be a null, and it'll just be, you can return Boolean or positive or negative to see if they're running or not. And now let's just check this event. And to do that, we'll just do SDL pull event. We'll pass in E. And then in here, we're just going to check to see if this X close button is pressed. We'll just do if E.type equals SDL quit. We'll set running equals to false. And we can use the key states as well. So we can check to see if someone clicked the escape button. So key states, and then SDL scan code escape. Let's do running equals to false as well. And while we're in here, we'll just create our two other functions, or two other lines that are just going to check to see if we went up or down, since we're going to be using that for our paddle. And right here, we'll just get back to these soon. That's just a way to run that, and we'll jump back to these in a little bit. But now it's just going to check for these things. If it's closed or not, then it'll close the program. And render. Let's go ahead and actually, as you can see, there's no screen, there's no background or anything, so we're going to create a background and actually draw it to the screen. So to do that, let's go ahead and set the color. And SDL render draw color. And then renderer. And you can pass in this hex color. You can also pass in something out of 255, either way. But we're just going to set it all to black. And alpha right there. Doesn't matter. And now we'll just clear the screen. And it's going to clear the screen with a current color. So now it's just going to basically just draw black over the whole entire screen. And I know we had that color above there that we had set. And we're using that color, the SDL color we had made, to actually have the color for a game, so the font and the paddle and the ball, and we had it as color, so we'll just do R, and we'll just set it all to white. So let's just set it right here, color.g and color.b. So that's going to make it so it's all white. So the background is going to be black and just everything else is going to be white. You guys can go ahead and change around stuff like that if you guys want. And now we're going to have to change the color after we draw it black. We're going to go down here. So when we actually draw the rest of the game, we'll change the color to be the appropriate color. And you could have set the 225 right here, but I'll just go ahead and put in these variables. And we're also going to want to push our buffer to the screen. Do that with SDL render present. And we pass in the renderer. And that's just going to make it so it draws everything to the screen. So anything we want to draw, we'll just have it right here. Because it's going to draw the background. It's going to set the color to black, draw the background. It has this frame count. We set it to white, which is the color we have set. And then we can draw the paddle, we can draw the ball, we can draw the score, and then we push it all to the screen right here. So now let's go ahead and we're going to go ahead and create our paddle, we're going to create our ball, and we're going to create a scorekeeper. And then we'll start working on the mechanics and the logic in this update function. So right here we'll be using SDL rect. And this rectangle is just going to have an X and Y coordinates, and it's also going to have a width and a height. And you can use it to draw directly to the screen. So we're going to be using that for our paddles and our ball. And we can also use that for a scoreboard where it's going to have a font pushed onto it, but it's just going to be a rectangle still. And we'll just create one called left paddle, one called right paddle, and we'll have our ball, and we'll have our scoreboard. SDL doesn't have anything like SDL circle or anything like that where it just draws a circle automatically. You can draw points, you can draw lines and rectangles. There are ways to draw circles. Check below in the description. I'll have a link where you can create a circle as well. It's a simple circle. You guys are going to have to change around some of the math because the X and Y point that we're going to be using is going to be the top left corner of the rectangle, and we're going to be adding the height and the width for collision checking and whatnot. So whenever you do the math with a circle, you're going to have to know that the X and Y coordinate of the circle is going to be the middle of the circle, and the size is going to be the radius. So the collision is going to be a little bit different for that. We're also going to have the velocity of our ball. It's going to have a velocity of for its Y and X. And we'll also have our string for our score. I'll set that right there. And we'll have a score individually for both paddles. And we'll also have something saying whose turn it is. So let's go ahead right now. We can just create this simple function where you can just write to the screen. And in this, we have our scoreboard. So now with a scoreboard, we're just going to put something onto it. So let's just pass in some string to pass to it. X, int Y. And there's a way you can just have it so it already knows to check for this ls and rs, but this function will be a simple function. You guys can go ahead and use in different programs as well. So I'm going to make it sort of basic. We're going to create a surface. And the surface is going to load in the fonts, and we'll push it to a texture, which is going to be rendered to the screen with the scoreboard rectangle. So we'll create our texture as well. And let's also make sure the font is loaded. Like I said, you can just do if font equals null. Could have done this before, but just to make sure that's correct. Then you'll just want to say font not found, extra failure, so you can do that right here. Oh, where did this jump to? I deleted that. So you could do that right there, or you could have done in the main function whenever you started it, but that's just a reminder to check to make sure the font's loaded, in case you're getting some sort of error or anything. And now we'll just create a character variable, a char, using this string. So we'll just do convert it over to a character, a char, and because that's what the SDL needs to be able to draw it to the screen actually. I'll just do surface equals TTF render text solid, and we'll just pass in the font, pass in this char, and pass in the color, and now I'll just do texture equals, and then SDL create texture from surface. You pass the render and you pass in the surface. So this SDL create texture from surface just takes in what was generated here, passes it to the surface, because that's what you're going to need to use to draw to the screen. If you actually have the surface of, say, like an image or something, you can use it to manipulate the image, flip it around, or manipulate per pixel, and then you can turn it back into a texture so you can use manipulated images in your program. And there's a lot of things that this is useful for. Now we'll just set our scoreboard to scoreboard.w, and we'll set that to surface w. That's the width, and scoreboard height, we'll set that to the height of the surface, because technically if there's a different amount of letters in there, the width and height can change, usually just the height. And we'll do scoreboard .x, and we can set that to x, and we'll also do scoreboard -w, and we'll do the same thing for the y, which is the height right here. There's possibly a better way to do this, because we're going to be taking these coordinates, but we're going to calculate it. We're trying to get it in the middle, because based on the size of the text, it could be thrown off a little bit, it could be bigger, it could be smaller, based on how many characters and how many letters are in the text. So we're just setting that to make it so you can kind of form it a little bit better onto the screen. And we'll just do SDL free surface. And we'll pass in the surface right here. And SDL render copy, render texture null, and scoreboard. And SDL destroy texture. Pass in the texture right here. So we're just freeing up the space from the surface. We're actually pushing it to the screen. The render copy, and then as soon as we do this right here, present, it'll display it. And then we're just also getting rid of the texture. So right down here, we can go ahead and actually display our score. We can just say write. You can write score, and we can also pass in the x and y. For that, we're just going to say width divided by 2, and then we'll do plus font size. This is going to make it a little bit more in the middle, and font size times 2. That's for the y. And for you guys that don't know, x and y coordinate isn't something like this. It's not 0, 0 down here escalating. It's actually 0, 0 up here. So as it goes down right here, the y is growing, and as it goes to the right, as usual, the x will grow. So we're just setting it to y is font size times 2, so it's going to jump down here a little bit, and then it's going to jump to the middle, and that's the point of that. So anytime we're going to be drawing something, when we're messing around with the coordinates, just remember that this right here is 0, 0, and as it goes down here, it's going to be growing. So now we need to go ahead and initialize the size of our paddles and the balls and draw them to the screen. We can do that right here. So it's going to be pretty simple. You guys can play around with the size that you want. We'll set the score to 0 first off, and we can also do right here, we'll do left paddle .x, and set that to 32, and left paddle .h, and set that to height divided by 4, so then it's going to be a fourth of the screen. Then left paddle .y, and in here we'll just set it to height divided by 2 minus L paddle .height divided by 2. So that's just moving it into the middle of the screen, because it cuts the screen in half, and then it cuts the board in half and brings it up just a little bit. So it's going to make it so the paddle's in the screen. 32 is going to bring it out a little bit, so it's going to be out. So you guys can just rounded these things, make it so the paddles different sizes, different anything like that. And then this right paddle, we're going to have some of the same sizes, so we'll just set it to the left paddle for the same thing. And now we're just going to move it to this side. So to do that, we'll just do left paddle or right paddle equal .x equals width, and then minus our paddle .w, because it's going to have the actual width of the triangle. So if I just set it to width, it's going to be off the screen because it's going to be right here, and it's going to grow further outwards. So we're going to subtract that, and then we're also going to subtract 32. So it has the same margin as the other one. And we can create our ball. We'll just do ball equals ball width, ball height, and we'll just set a variable called size so we can keep track of the ball size a little easier. We're going to be using that a few times. And we'll go up here and create that ourselves. Let's do define size. Oh. And we can set the ball size to be 16. Remember, if you're using the circle that I'm going to have in the description below, the size is actually going to be the radius, but for this, it's going to be, say 0, 0, here's the rectangle, it's going to go down 16 and 16, that's going to be the size of the rectangle. But the radius of the circle, it's going to be the point in the middle, and it's going to grow out 16 and go all the way around it. So let's just go right here, we set that size, and along with that, we're going to be creating a function called serve. So every time the ball goes out, someone gets a point, we'll just serve the ball again, and that's why we're keeping track of the turn. Because you can see right here, we had this boolean for the turn, so we're just going to keep track of whose turn it is. You can just do void serve. And in the serve function, we can actually reset the paddles to be in the middle, so we can copy their Y. So we'll just copy this one right here. And then the R paddle will be at the exact same height as well, or the same Y on the Y axis. Paddle.Y, and then right there. That's going to make it so they both go to the middle of the screen when we're serving. And when we also serve, we're going to check whose turn it was and where the ball is going to go, and we're going to reset the ball's velocity. We can also do right here, so we'll just do if turn. So we'll just say if turn is positive, we'll set it to one team, and if it's negative, set it to the other team. Doesn't matter which one's which. And we just do ball.x equals left paddle dot x plus, and then you can just space that out a little bit. So you can just do left paddle dot w times 4, and we'll set the velocity right here. So ball x equals ball speed, and divide that by 2. So the initial serve can be a little slow. And right here we can set the ball speed. So define ball speed. And we'll also create another one for just the speed. This will be the speed of the paddle. And these could be the same things. You can rearrange these, mess around with these numbers. You can do this with all these just to see what you like best. And we'll set this ball speed to 16. And we can set the player speed and the enemy speed to this 9 right here. And we'll go back to the serve function. So now it's setting it there. And we can also reset this right here. This doesn't need to be here actually, because it's going to be set that way either way. And then we'll just copy this right here again. But this is going to go to the right paddle. And we're going to subtract it. So it goes the left to the right paddle. So basically, if you don't understand, it's just checking to say if it's left player's turn, that means turn is true. So it's going to take the left paddle, and then it's going to move it over just a little bit. If it's the right one, it's going to take the right paddle's X, and it's just going to subtract a little bit and know where to put it. And the Y for the ball also needs to be set so it can be at the correct spot once again. So let's do ball.y, and we'll set it to the same thing we had set here below. No, we didn't have anything there. So we'll initialize it right here for the first time. So we're just going to put it in the middle of the screen, so we can do that. It's just height divide by 2. And as we did earlier, we'll do size, which is the size of the ball, the height of it, divide that by 2, so then it'll go directly in the middle of the screen. And now we'll just switch the turn so it knows next time that it's the other player's turn. If you guys are wanting to make it a little more complicated, you can set a score limit to say someone wins, or you can make turns based on who gets the point, switch around some things. And we'll also set the velocity of y back to 0. It'll only change once it hits the paddle. So now our update function, we're going to be actually moving around things, we're going to be changing things. Here in input, since we have our paddles created, we can do left paddle and then .y, and then we're going down. So remember, down, it means it's increasing in the y, so we're going to be plus. And let's do speed, and then right here it's going to go down on the y, so let's pass in speed right there. So we can go ahead and compile this, see how it's going so far, check any errors. And as we can see, we had an error right here. I think I just maybe wrote something wrong. Just jump into that. And right here, it needs to be capital F. And oh, I forgot the Y on this. If you guys are using an IDE or some sort of vector text editor, I might be giving you these errors before we even see them. So it was right here. In our update function, we can set that right here. So to do that, be really simple. We'll just take the left score, and then we'll add a spaces between it, and we'll put in the right score. So we'll just say score equals, and then do SDD2 string, because it's going to be an integer, and then left score, and plus, and give it 3 spaces, then SDD2 string, and then right score. So that should make it so it works. Won't have any errors. And now we can see we have our game. There's a window. Click escape, it'll close it. Click this as well, it should close it. And it prints out the score, which is 0, 0 for now. And we don't actually have it drawn the rectangles. So let's go ahead and draw our rectangles for the paddles and for the ball. So we're going to jump back into this render function. And we can just draw them right here. That's right. We set the font for white while we're doing that one in the actual right function. But for the other things, we're going to have it below this to make sure it's actually white. Because otherwise it's still set to black up there. So we'll do SDL render fill rect. And that's just going to fill in a rectangle on the screen with whatever color. So we can just pass in render, and we can pass in the rectangle, which is going to be the left paddle. And we can do that again for all of them. Just do ball, and we can also do the right paddle. If you wanted to, you can change the color again. You can also draw the scoreboard, and then you can do that before you draw the score, so it can have a background for the scoreboard. Or you can change the font color and have the background be white for the scoreboard, and then I'll draw the font on there as black. I'd move this outwards, but let's go ahead and throw this in actually, since it's going to flip to negative while it's in this one, because it's going to be going in the opposite direction. So let's just change that to be a negative, and also along with that, we're going to go ahead and make sure the paddles are in the right position. So in the serve right here, we can just leave it as is, and in main, we're going to go ahead and look right here. So our problem here is that we're not actually setting the width. So let's do left paddle dot width, and we'll set that to 12. And now everything should be working. And as you can see, it generates the scoreboard, it generates the paddles, and we actually made it so we can move the paddles up and down. And now let's make it so the paddle can't actually pass the screen. So every time it passes the screen, it goes back, and we'll do that for both these paddles. And to do that, we're just going to go into our update. And we'll just check to see if it's greater than the screen, if it's less than the screen, or the height. So we'll just do if left paddle dot y is less than 0, and left paddle dot y equals 0. And then right here, we can do left paddle plus left paddle height, because say paddle's right here. If you want to check to see if it's below the screen, you're also going to have to add the height to it. And then if it's greater than height, then left paddle equals height minus left paddle dot height. And let's do the same thing for the other one. And as you can see right there, that needs to be 0. And we'll just do the exact same thing right here. We'll just switch everything to right paddle. And how the right paddle is going to work, it's just going to use the speed and just go towards the ball. So we can set this right here. And just do if, and we'll check it if it's in the middle of the paddle. So we'll just do if ball.y is greater than, and then we can say right paddle.h plus, and then we can check for half of the paddle size, and we'll just do right paddle.height. So if it's greater than that, that means it's below it. We're just going to move this upwards. So to move it upwards, we'll just do right paddle.y minus the speed. And we'll just do the exact opposite right here. We could say if it's less than it, then it'll go up. Now that we've got that going, the paddles move. Now we just need to do the mechanics for the ball to move. And for the ball to move, there are many examples out there, many different programs and different ways to make it to the ball. It's different physics. We're going to go ahead and doing a simple physics where I'll link in the description where someone else explains it a little bit better and explains how to do it all in detail. But basically, where the ball hits on the paddle, it's going to see the distance where the ball is on the paddle, if it's in the middle or if it's on the top or the bottom, and it's going to fling it off with an angle of 75. So it's going to see the distance on the paddle, and then it's also going to normalize that distance, so it's just from 1 to -1. It's going to be a float, so there's going to be decimals, and then it's going to use the angle 75. That's going to be the max. So when it's at the very end of the paddle, it'll go off at 75. If it's in the middle, it can go off at 0, and we'll just do that to calculate the angle. So we're just going to do that for whenever it touches the wall, or also whenever it touches the paddle as well. But for the wall, we can just have it set to flip over. So whenever it hits the wall, if it's left or right side of the wall, I'll just flip over. If it hits the top or the bottom, it'll flip over the other velocity. So let's do if ball y is greater than, well, if ball.x equals 0, that means it hit the right wall. And we'll just do vel_x equals -vel_x. And do the same thing over here. So ball_x plus size, which is the width of it and the height. We'll just flip it over right here. And set that to height set that to width right here. And we'll do the exact same thing for the height as well. We'll switch these to y. So ball y to size equals height. And we'll just change these ones to the velocity of y. Now, like I said, we're going to be doing the same thing, but for when it hits the paddle. But instead of just flipping it, it's going to calculate the angle and everything. So we're going to just do if. In this if statement, we're going to be checking for the right paddle, and we'll do another one for the left paddle. And there's several ways to check collision, but SDL has their own formula called SDL intersection. And it just checks if two rectangles, they have an intersection. There's a way also, say you have your circle, and your circle is just going to have an SDL point for the center of the circle. There's a function where you can check to see if this point is within a rectangle, and it'll return true or false for that. So if you're doing the circle instead of a square for your ball, you can do that. And then we'll just pass in the two things. We'll pass in the ball, and then we'll pass in the right paddle. So it's going to return true if they're touching, and if they're touching, we're just going to flip around some things. So the first thing is, well, I'm going to create this relative y-intercept. So we're going to see where on the paddle it's touching. And to do that, we'll just do right paddle dot y, and then plus right paddle dot height divided by 2. And then we'll also do minus, in parentheses again, the ball plus the size divided by 2. Now we've got the relative, we're going to have to normalize it so we can actually change it, that number of the distance from -1 to 1. So we'll just create a new double, we'll call it norm. For normalize, and we'll do relative divided by the right paddle dot h divided by 2. And then we're also going to figure out the bounce angle. So to do that, we'll just do double bounce, then norm, and then we're going to be setting it to 75, like I said, as the max angle. And 75 will be this right here, 5, and then pi divided by 2. I'll get eventually the code for everything in the end, but the number for pi, I'll just have that in the description. You guys can look that up. But let's go ahead and copy it from my example right here. This is the full number, but you can just do 3.14 if you want to. And we'll just add it right here. And there we have pi. And that's just number for 75 right there. That's an angle of 75. And now we're going to want to change the velocity based on that right there. So the velocity will be, for the right paddle, it's going to want to do a negative and then ball speed times cosine of the bounce. And then velocity of y, we'll do ball speed times negative sine of bounce. And now we're just going to want to do the exact same thing for the right paddle. So I'm just going to copy these right here, or for the left paddle. And it's going to be the exact same numbers. We'll just switch everything over to left paddle. And it's going to calculate it that way. And then also in this left paddle, this right here will be positive. And that's a simple way to check it. And now we just want to make it so if it touches on one of these walls, it changes the score. As you can see right here, changes the wall right here. So if it's touching the left wall because it's 0, that means the right score is going to go up. So we'll go up right there. And then right here we can do the left score, make that one go up. And as soon as it touches it, we don't actually need to flip when it touches the wall. We'll just do serve. And set this one to serve right here. And let's do that one before, because it's going to need to change it before it calls the serve function. And now let's go ahead and actually make it so the ball can move based off the velocity. So let's do ball.x plus equals velocity x, and ball.y plus equals velocity y. Right here. There's misspelling. Probably caught that. Let's check right here. Oh, as you can see, the ball went right past the screen. We'll check in a second. But as you can see, this is going right. It's not passing the screen at all. And there's a height right there. That one didn't pass it either. And it's actually going to where the ball is. The ball's probably in that direction. It's probably further down. But let's just check right here in the update to make sure it's actually checking for the right side. We can just do, instead of equals equals, because it's changing at the speed, we'll just check if it's less. So if it's equal or less, then along with this one right here, it's equal or less, or it's greater. Oh no, this one's greater. If that's greater, that's greater, and if that's less, if the width is less. So you see we have our Pong game here. If I pass, if I let it get past me, as you can see it hit him, scored, and there it is right there. It looks like he's going down every single time, so we'll just go ahead and check that. So this right here is correct. It's plus and minus. I don't know where that error is coming from, but it's correct as it is. And also, to fix up any other glitches or any bugs, I just took this intersection, these two intersection functions, and set them to the top of the update, so it does that first. And along with that, I'm going to rearrange some of these so I can just do the calculations in the correct order. So after the intersection, I'll just move this right up there. And after that, We'll check for the serves. Set that there. The order doesn't particularly matter, but I just have it here because sometimes it could have a little things that are messed up. I'll change the velocity after these serves. I had the string set up here at the very beginning, but I'll just move this down here after the velocity. Realize this right here can be a single thing. Set that to OR, and I'll set that right up here. I believe I said the right thing, but did the wrong thing. I'll switch these right here. I wanted the velocity up there. And also I realize right here in the angle, I had it divided by 2. It actually needs to be divided by 12 in order to get 75. Now if we were to go to check it, we'll just compile it right here and run it. And you can go ahead and play your very own game, first person of Pong. It's really simple. It has serve, it checks the boundaries and all the coordinates to make sure there's no collision, make sure your paddle's on the screen. Your other paddle will follow the ball. You guys can go ahead and change around some of the numbers, go ahead and change around anything you want, change the colors, and you can even make the game have new features. I'll show you this short clip right here of a game that I made a long time ago. It's Pong, but there's this boost mechanic, and there's a lot of these colors. The scoreboard is actually these dots in the middle that change with the color based on the score. But yeah, that's just the new version of Pong. But I hope you guys enjoyed this tutorial. I'll have everything in the description you guys need if you guys are interested in the source code yourselves. You guys can ask for it, and I'll post it on GitHub or some sort of paste bucket or something like that. If you guys are interested in looking at that, if you have any questions, leave in the comments below. If you guys have any ideas or any things you guys would change yourselves, leave in the comment as well. And once again, if you guys are new here, reminder to subscribe. Our goal is to reach 500 subs by the end of the month. And if you guys can go ahead and like the video, it helps me make more videos like this. Thank you guys again so much for watching this whole video. It really helps my channel out a lot and really helps me make more content just like this. Hope you guys enjoyed it. Can't wait to see you guys next time. See ya.